Hello everybody. We continue talking about difference in statement and results, and in previous video we talk about different materials. We apply one material to wall construction, to all part of construction, and see that stresses are not depend from which material we apply to wall construction. Deformation, yes, it change their value in dependence of material elasticity model, and difference in elasticity model is the same as difference in total deformation. But in most cases, for real construction, we have another situation. We have situation when we have some parts created from one material and other part from another, and we have here two different type of construction. They have a similar geometry, they have similar boundary condition, they have similar contacts are linear, but they have different materials for different parts. For first construction, we have crank, which created from aluminum alloy, and all other parts, including bolts and base, created from steel. And for second construction, we have base created from aluminum alloy, and all other parts, including bolts and crank, created from steel. So let's take a look to the total deformation, and we see that we have almost the same value of maximum deformation, but we can see that we have very different behavior. The scale factor of both pictures are the same, but stress distribution are very different. And we can see that on this simulation, where base created from aluminum alloy, our crank are almost rigid, and almost all deformation became to the base. For this construction, the base almost rigid, and maximum deformation for this part of the crank. So if we have different distribution of deformation, of displacement, we need to understand that our stresses, picture of stresses, will be also not equal. But if we take a look into the number, we see that difference are less than 1%. First of all. Second, we see that stress distribution are almost the same for wall construction, but for wall construction it's not very good situation to take a look at this picture, so we can check stress distribution for only one part, and we choose base. We have almost similar picture of stress distribution, and we see that we have bigger difference. It's about 5%. Here we have 200 of megapascals, here we have 190 megapascals. And much more interesting that we have different picture of distribution. We see that here picture distribution, stress distribution look like this one, and here it look very different. so it has something like this one. In previous simulation, it has something like that. So we see that we have some difference in behavior. We see some difference in maximum values and so on. We have some difference here. We have some difference here, and we have some difference here. So if we have different materials and construction created from different materials, depending on stiffness of these elements of this part, we will have different stress distribution, and this stiffness can become from geometry and can become from materials. So if we have different geometry and one material, we will have different stresses. It's logical and it's very simple. But if we have one geometry and one material to wall construction, we have one stress distribution for different type of materials. But if we have one construction and some parts will have one material, some parts will have other material, depending on distribution of materials for parts of our construction, we will have different stress distribution and different type of deformation. And this difference we obtain in a linear behavior with linear material and linear contacts. If we apply non-linearities, for example materials or contacts, and this is and this calculation creates for non-linear contacts frictional, materials are linear, contacts non-linear. And if we take a look into our deformation, we will see a bigger deformation, about 20% difference with linear contacts, but the same type of distribution for both construction. If we take a look into stresses, we see some difference in behavior. For example, here we have 2000, almost 3000 of megapascals, and here we have almost 1200. All other stress distribution, especially stress distribution around less than yield point, will be almost the same. But if we take a look into stress distribution of only one base, we see some difference in stress distribution. We see that those plates have, with the similar mesh, have 440 megapascals of maximum, and this place will have 370. So we have around 70 megapascals, it's about 17% of error. And also we see difference in stresses here and here. So it means that if our construction created from different material with different stiffness, with different elasticity model, with different Young model, it means that we cannot calculate wall construction with one material, because we will have a very big problem of accuracy of our result. So if we need to find a proper combination of material, unfortunately we need to do all type of combinations and check them all. And do this check very carefully, and do not only for wall construction and for these numbers of maximum value, but for stress and deformation distribution you need to do check also. Thank you. Hope it will be interesting and important to you. Write a comment.